Hello everyone, this is Sravanthi, working as Assistant Professor, Department of Chemistry in Institute of Aeronautical Engineering. Today we are going to discuss about definition and terminology of electrochemistry and corrosion. So first, what is define voltaic cell? So voltaic cell is a electrochemical cell. It is also called as electrochemical cell, which converts chemical energy into electrical energy. Which converts chemical energy into electrical energy is called voltaic cell. It is also called as electrochemical cell. So here voltaic cell is electrochemical cell that uses spontaneous redox reactions to generate electricity. So simply we say voltaic cell is an electrochemical cell which converts chemical energy into electrical energy is called voltaic cell. So what is electrolytic cell? So here electrolytic cell which converts electrical energy into chemical energy, that is completely reverse to electrochemical cell. So electrolytic cell which converts electrical energy into chemical potential energy or chemical energy. So this process is known as electrolysis or otherwise decomposition of electrolyte by passing electricity. The process is also called as electrolysis. So here electrolytic cell, in this case which converts electrical energy into chemical energy is called electrolytic cell. The main purpose of this electrolytic cell is converts reactants into more useful products. So this is completely reversed to electrochemical cell. In electrochemical cell which converts chemical energy into electrical energy. But in electrolytic cell which converts electrical energy into chemical energy. So the main purpose of this usually to convert reactants into more useful products. This is called electrolytic cell. Next one is why is salt bridge used in the construction of a cell? So cell means it consists of one anode and one cathode. So number of cells connected in a series is called battery. So in the cell construction, why is a salt bridge used in the construction of a cell? So here they allow the movement of ions from one solution to another solution. For example, zinc and copper. So zinc electrode dipped in zinc sulfate solution. This is a zinc electrode and this one is copper electrode. So this zinc electrode dipped in zinc sulfate solution and copper electrode dipped in copper sulfate solution. So these two electrolyte cells, these two electrolyte solutions connected by a salt bridge. This is called salt bridge. So they allow the movement of ions from one solution to another solution without mixing up the two solutions and complete this electrical circuit. Complete the electrical circuit. So to maintain the electrical neutrality of the solution in between two half cells. For example, here zinc electrode dipped in zinc sulfate solution. It is one half cell. So usually zinc acts as anode. So this half cell is called oxidation half cell. For example, copper electrode dipped in copper sulfate solution. So it is another half cell. So these two half cells connected in a series, that is called complete cell. So these two half cells are connected by through a salt bridge. So this salt bridge is mainly used for the movement of ions from one solution to another solution. They allow the movement of ions from one solution to another solution, and also it is mainly used for to maintain the neutrality, electrical neutrality of the solution in the two half cells. That is the main use of salt bridge. It maintains electrical neutrality in between two half cells and it allows the ions, the movement of ions from one half cell to another half cell. So next one is define battery. So the term battery is a group of two or more electrochemical cells connected together electrically in a series. So just to discuss what is meaning of cell, it consists of one anode or one cathode is called cell. So the number of cells connected in a series. So that means number of anodes and number of cathodes present in that. So number of cells connected in a series is called battery. So battery is a device in which two or more electrochemical cells connected in a series. So what is the meaning of electrochemical cell? So which converts chemical energy into electrical energy is called electrochemical cells. So two or more electrochemical cells which converts chemical energy into electrical energy is called battery. So what is irreversible cell? The cell in which the cell reactions are not reversible. The cell reactions are not reversible. Best example is primary batteries. Primary batteries, because primary batteries in that the cell reactions are not reversible. Once we are using these batteries, it becomes dead. The type of reactions are called irreversible reactions or irreversible cell. So the cell reactions are not reversible. Once we are using that battery or cell, it becomes dead. Best example is primary battery or torchlight batteries, remote batteries, etc. Best example of irreversible batteries or irreversible cells. So what is a reversible cell? So the cell reaction in which in that cells, the cell reaction is reversed by passing direct current in opposite reaction or opposite direction. So the best example is secondary batteries. Secondary batteries. So what is reversible cell or reversible batteries? The cell reactions are reversed. Once we are using these batteries, again it can recharge by passing electricity in opposite direction. Best example is secondary batteries such as, for example, mobile batteries, lead acid batteries, lithium ion batteries. So when we are using these batteries, again we are using recharged by number of cycles through charging and discharging. Reusable batteries. So that means these cell reactions are reversible. So these batteries or cells are called reversible cells or reversible batteries. Best example, secondary batteries or all rechargeable batteries are secondary batteries or reversible cells. So what is redox reaction? So an oxidation and reduction reaction. Oxidation. So what is the meaning of oxidation? Loss of electrons. Reduction, gain of electrons. So an oxidation and reduction reaction in any chemical reaction in which oxidation or number of molecular atoms changes by losing or gaining of electrons. So redox reactions means in that cell both oxidation and reduction reactions takes place. So oxidation means loss of electrons, reduction means gain of electrons. So here an oxidation or reduction reaction in any chemical reaction in which oxidation number of molecules or atoms changes by losing or gaining of electrons. So both reactions takes place in that is called redox reactions. So the combination of oxidation and reduction is called redox reactions. So what is oxidant and reductant? So in these redox reactions, the reductant transfers electrons to the oxidants. Transfers electrons to the oxidant. Thus in the reaction, the reductant loses electrons and is oxidized and oxidant gains electrons and is reduced. So simply says, for example, zinc electrode. So according to electrochemical series, zinc acts as anode. So when zinc undergoes oxidation, so it loses electrons. So this is called oxidant. Zinc acts as oxidant. It loses the electrons into the electrolyte solution. For example, copper. So copper, according to electrochemical series, it acts as a cathode, reduction quality. So copper, gain of 2 electrons, then deposit there as copper. So it gain of electrons, so it acts as a reductant. So here in redox reactions, the transfers electrons to the oxidant. Thus, in the reaction, the reductant loses electrons and is oxidized, and oxidant gains electrons and it is reduced. So simply we say oxidant means loss of electrons, reductant gain of electrons is called oxidant and reductant. So next one is define reduction potential. So reduction potential, the tendency of an electrode means which conduct electrons. So it is a metal or metallic rod which conduct electricity is called electrode. So here reduction potential means the tendency of an electrode lose electrons. The tendency of electrode to lose electrons when it is contact with solution of its own ions. For example, copper electrode dipped in copper sulfate solution. This is the copper electrode dipped in this copper sulfate solution. So the natural tendency of electrode loses electrons when it is dipped in same own salt of the electrolyte solution. So for example, copper electrode, it is dipped in same own salt of the electrolyte solution means in that electrolyte solution it's present electrode copper ions in that electrolyte solution. So when we dip in this copper electrode in this copper sulfate solution, so this electrode loses their electrons. Electrode to lose electrons when it is in contact with its own salt solution. That means it gains negative charge and deposited there as copper metal ions. So in this case it develops reduction potential. So what is the meaning of oxidation potential? So here the tendency of an electrode to, so here gain of electrons, here loss of electrons. So define reduction potential means the tendency of electrode to gain of electrons when it is dipped in same own salt solution. In this case it develops reduction potential. So what is the meaning of oxidation potential? So the tendency of an electrode to lose the electrons. For example, zinc electrode. This is dipped in same own salt solution means it is a zinc sulfate solution. It is dipped in zinc sulfate solution. So in this case, when we dip zinc electrode in this zinc sulfate solution, so according to electrochemical series, zinc metal acts as anode. So that means it undergoes oxidation. It gives the metal ions into this electrolyte solution. So zinc undergoes oxidation, then loss of 2 electrons. So in this case, it develops oxidation potential. So the tendency of electrode to lose their electrons when it is contact with solution of its own ions is called oxidation potential. But reduction potential is the electrode when we dip it in the same own salt solution. So electrode gain electrons, gain of electrons. So in this case, it develops reduction potential. So the potential difference between these two potentials of electrodes, either oxidation potential or reduction potential, is called cell EMF, electromotive force. So what is electrode potential? So now we'll discuss already reduction potential and oxidation potential. So now let's discuss what is electrode potential. So electrode means it is a metal or metallic rod which conduct electricity is called electrode. Electrode potential means strength of electrode. So here the tendency of an electrode to lose or gain of electrons when it is contact with own ions. So the tendency of metal to lose or gain of electrons when it is contact with their own salt ions. For example, zinc electrode dipped in zinc sulfate solution, copper electrode dipped in copper sulfate solution. So in this case, zinc lost their electrons. In this case, it develops oxidation potential. Or otherwise, copper, when we dip it in copper sulfate solution, it gain of electrons from the electrolyte solution. So in this case, it develops reduction potential. So the natural tendency of metal to lose or gain of electrons when it is dipped in same own salt solution is called electrode potential. So what is the meaning of reference electrode? Define reference electrode. So reference electrode is an electrode of standard potential of with which we can compare the potential of another electrode. So simply we says reference electrode. Reference purpose we are using this electrode to known potential of electrode. By using this one we can calculate the another electrode potentials. So it's called reference electrode. So reference electrode of standard which we can use it for determination of another electrode potentials is called reference electrode. So generally there are two types of reference electrodes are there. Primary reference electrode and secondary reference electrode. So primary reference electrode best example is standard hydrogen electrode. So reference electrode, it is mainly used for reference purpose. That means already we know the potential of that electrode. So by using that electrode which we can determine the another electrode potentials. That is called reference electrode. So there are two types of reference electrodes. Primary reference electrode and secondary reference electrode. So primary reference electrode best example is standard hydrogen electrode and its electrode potential value is 0 volts. So all temperature its voltage standard electrode potential of standard hydrogen electrode is 0 volts at all temperatures. So secondary reference electrodes are calomel electrode, Winhydron electrode, glass electrode. So these all are the secondary reference electrodes. So these reference electrodes are mainly used for determination of another electrode potentials. So next question is write the nearest equation for the electrode reaction at 298 Kelvin. So generally nearest equation mainly used for determination of electrode potentials and concentration of solutions and also used for number of valency electrons involved in that reaction and also used for determination of pH. So the nearest equation for the electrode reaction at 298 Kelvin is E equal E naught minus 0.0591 by N log products by reactants, or otherwise you can write sometimes E equal E naught minus 2.303 RT by NF log concentration of products by concentration of reactants. Concentration of products by concentration of reactants. So here in this case E equal to single electrode potential, E naught is the standard electrode potential and R is the gas constant. Its value is 8.314 kilojoules. So R is the gas constant. Its value is 8.314 kilojoules. And T is the temperature. It's equal to 298 Kelvin or 25 degrees centigrade. When we convert it into Kelvin, 298 Kelvin. And N means number of valency electrons involved in that reaction. And F equal 1 Faraday. So 1 Faraday equal how many coulombs? 96,500 coulombs. So nearest equation for the electrode reaction is E equal to E naught minus 2.303 RT by NF log concentration of reactants products by reactants. So when we substituted in the formula R value T, F, so finally we'll get E equal to E naught minus 0.0591 by N log products by reactants. So here also E means single electrode potential. So single electrode potential means strength of that electrode or the tendency of metal to loss or gain of electrons when we dip it in say own salt solution is called single electrode potential. So E means single electrode potential, E naught means standard electrode potential. So already we know the potential of that electrode potential of that electrode. So E naught is the standard electrode potential minus 0.0591 by N. N means number of valency electrons involved in that reaction. Log products by reactants. So this is the nearest equation for the electrode reaction at 298 Kelvin. So now let's discuss cell is made from aluminum and silver half cells. So aluminum and silver half cells. So which electrode is the anode and which is the cathode? So in this cell reaction, cell is made from, it consists of one anode and one cathode. So compulsory it's present two electrodes. So one is acts as anode and the one is acts as cathode. So in that given cell is made from aluminum and silver half cells. So which electrode is the anode, which one is acts as cathode in this aluminum and silver? So here the aluminum half cell is more negative. More negative means it acts as anodic nature. It undergoes oxidation. So aluminum half cell is more negative than silver half cell. So at aluminum electrode or aluminum atoms lost electrons, that means aluminum acts as anode and here silver acts as cathode, because the aluminum half cell is more negative than silver half cell. So at aluminum electrode or aluminum ions lost their electrons because it acts as a anode and oxidation takes place. So aluminum is anode and silver acts as cathode. So aluminum undergoes oxidation because it is having high anodic nature, more negative nature compared to silver. So aluminum acts as anode, silver acts as cathode. Define corrosion. So corrosion means any process of deterioration and consequent loss of solid metallic materials. Any process of destruction or deterioration and consequent loss of solid metallic materials through an unwanted chemical or electrochemical attack by its environment. So then starting at its surface is called corrosion. So simply basis, corrosion is loss of metal by attacking environment or atmospheric gases on metal surface. The best example is rusting of iron. The best example of corrosion is rusting of iron. So loss of metal by attacking environment or atmospheric gases on metal surface is called corrosion. And one more definition also there, the natural tendency of metal, it undergoes their original form. That means generally metals available in nature, ores or their minerals. For example, metal sulfide, metal oxide, metal nitrate, it is available in mineral or ore form. But our only purpose, we extract the metal from these compounds or these mineral compounds. So always the natural tendency of metal try to get oxidized or their original position. So that is called corrosion. But most of the cases, metal undergoes corrosion by attacking environmental conditions or atmospheric gases. So the best example of corrosion is rusting of iron. And next one is, which type of metal oxide film cause rapid and continuous corrosion? So which type of metal oxide film or layer cause rapid and continuous corrosion? So the volatile oxide layer volatilizes as soon as it is formed. So thereby leaving the underlying metal surface exposed to further attack. So this causes rapid and continuous corrosion. For example, any metal, when it is contact with or it is undergoes volatilizes. First it is reacts with oxygen, then form metal oxide layer. But it undergoes volatile, that means sudden changes occurs, it evaporates metal oxide layer. So in this case fresh metal surface is available, so any other chemicals attacking on this metal surface. So the volatile metal oxide layer volatilizes as soon as it is formed. So when the metal interacts with the atmospheric oxygen or oxygen, in this case it forms metal oxide layer. So when it is formed, suddenly it undergoes volatiles. So thereby leaving the underlying metal surface exposed for further attack. So this causes rapid and continuous corrosion. And next question is which types of metal oxide film prevents corrosion? So which type of metal oxide layer prevents from corrosion? The metal oxide layer with fine-grained, tightly adhering impervious oxide film and highly unstable oxide film. In that case, it prevents from corrosion. For example, this is a metal where it reacts with oxygen. So in this case, it forms metal oxide layer on metal surface. This is the metal oxide. That means this metal oxide layer completely covered on metal surface. So in this case, this metal oxide layer is finely grained, tightly adhering and impervious oxide film, do not attacking any other gases on metal surface. That means it is completely covered the metal surface. So in this case, it acts as a protective metal oxide layer on metal surface. So in this case, it prevents the metal from corrosion. And also highly unstable oxide film. In this case also it prevents, that means unstable, that means noble metals which are form this type of metal oxide layer. These metals also prevents from corrosion. And next question is what is meant by rusting of iron? So the atmospheric corrosion of iron leading to the formation of a layer of reddish scale and powder of oxide on the surface. So this rusting of iron is the best example of corrosion when the iron metal interacts with oxygen, atmospheric oxygen. So in this case, it forms reddish color scale or powder on iron metal surface, that is called rusting. That is called rusting of iron. What is dry corrosion? So here, corrosion means loss of metal by attacking environment or atmospheric conditions. So the process is called corrosion. There are two types of corrosion, dry corrosion and wet corrosion. Dry corrosion, it is also called as direct chemical corrosion. Direct chemical corrosion. So this corrosion caused by direct chemical action of atmospheric gases, that which has, for example, oxygen, halogen with the metal surface. Direct chemical action of atmospheric surfaces, atmospheric gases such as chlorine, oxygen or hydrogen on metal surface. This is called dry corrosion or direct chemical corrosion. Next question is what is wet corrosion? So wet corrosion, it is also called as electrochemical corrosion. Electrochemical corrosion. So here a corrosion which occurs when conducting liquid in contact with a metal, or the metal is partially or completely dipped in conducting solution, or contact with a conducting solution or conducting liquid. So in this case, this type of corrosion occurs. So here there is a separate anodic and cathodic parts are there. Always corrosion concentrate anodic area only. So simply says wet corrosion means metal contact with a conducting liquid, or metal partially or completely dipped in conducting solution. So in this case, that metal undergoes this type of corrosion, wet corrosion. And it is also called as electrochemical corrosion. And next question is what is liquid metal corrosion? So this corrosion occurs due to the chemical action of flowing liquid metal at high temperature on solid metal or alloy. So what is the liquid metal corrosion? The corrosion occurs due to the chemical action of flowing liquid. That means metal contact with the liquid, or by mistakenly it is contact with liquid, or partially or completely dipped in conducting solution. In this case, it occurs this type of corrosion. So this type of corrosion occurs due to the chemical action of flowing liquid metal at high temperature on solid metal or alloys. And next question is What is porous metal oxide layer? So metal oxide layer means, for example, this is a metal where it is interacts with atmospheric oxygen. So in this case, it forms metal oxide layer. But if any cases, any reason, either any other impurities present on that metal oxide layer or any other chemicals are attacking on that, it creating cracks, that means pores or creating in that metal oxide layer. So in this case, it is decomposed, any other gases attacking through these pores. So that is called porous metal oxide layer. So in this case, that metal easily undergoes corrosion. So here, what is porous metal oxide layer means? It contains pores and cracks, and the atmospheric oxygen has access to the underlying surface of the metal through the pores or cracks of the layer. So thereby, the corrosion continues until the entire metal is converted to the its oxide. So simply says, when the metal interacts with oxygen, then form metal oxide layer. If any other reasons, that means any impurities present on that metal oxide layer or any other chemicals attacking on that, pores or cracks creating on that metal oxide layer. So in this case, that metal easily undergoes corrosion by attacking any other gases or oxygen passed through these pores, attacking on metal surface. So that metal is easily undergoes corrosion. So what is volatile metal oxide layer? So here also same, the oxide layer formed is volatile in nature. So when the metal interacts with the oxygen, here just now we discussed, then form metal oxide layer. But this metal oxide layer is volatile. So in this case, the nature and evaporate as soon as it is formed. So thereby leaving the underlying metal surface exposed to further attack. So in this case also, the metal oxide layer acts as non-protective. If in case pores are present in that metal oxide layer, in that case also this metal oxide layer is non-protective, because pores are creating on that layer, any other gases easily attacking on the metal surface through the pores. And here also same, if the metal oxide layer is volatile or evaporates, in this case also any other gases or chemical factors attacking on that fresh metal surface, so that metal easily undergoes corrosion. So in this case, that metal oxide layer doesn't protect metal. It is acts as a non-protective layer. And what is stable layer? So a stable layer is fine grained in structure and can get adhered tightly to the parent metal surface. So such a layer will be impervious in nature. That means it protects the metal on metal surface. So when the metal interacts with oxygen, then form metal oxide layer. If this metal oxide layer is stable, that means it is completely covers on metal surface and it is stable. So in this case, that metal oxide layer acts as protective metal oxide layer. Next, what is unstable layer? So if the metal oxide layer is unstable, so that metal oxide layer is easily decomposed back into metal and oxygen. For example, this is a metal where it is interacts with atmospheric oxygen, then form metal oxide layer. This is the MO layer. Metal oxide layer is formed, but it is highly unstable. So in this case, it is easily decomposed back into metal and oxygen. So here fresh metal surface is available, any other gases attacking on that metal surface. So it is a non-protective, the metal. So the oxide layer formed decomposes back into metal and oxygen. That layer is called unstable layer. And next one is, what are the types of theories of corrosion? So already we know that corrosion means loss of metal by attacking environment or atmospheric gases on metal surface is called corrosion. So there are two types of corrosion, dry corrosion and wet corrosion. So here there are two theories of corrosion. Two theories are two types, both are same. There are two types of corrosion, One is dry corrosion. It is also called as direct chemical corrosion. And electrochemical corrosion. It is also called as wet corrosion. So there are two types of corrosion. Dry corrosion or direct chemical corrosion. Wet corrosion or electrochemical corrosion. So write the effects of corrosion. So what are the effects of corrosion? So corrosion means loss of metal. So here wastage of metal in the form of its compounds. Wastage of metal in the form of its compounds. And also the valuable metallic properties. Loss of their valuable metallic properties like conductivity, malleability, ducticity, etc. So the more valuable properties are loss of the metal when it is undergoes corrosion. So the loss due to corrosion, the most valuable properties loss of metal when it is undergoes corrosion. So what is cathodic protection? So already we know that corrosion concentrate always anodic area. So cathodic area reduction reactions takes place but does not affect the cathode. Already we discussed previous classes in cathodic protection method. So here we'll discuss what is the definition of cathodic protection, cathodic coatings. So cathodic coatings are obtained by coating a more noble metals. More noble metals. Noble metals means here silver, iron, platinum or otherwise high corrosion resistance metal. So cathodic coatings are obtained by coating a more noble metals or less active metals having high reduction potentials or lower oxidation potential than the base metal. So what is the meaning of base metal? Which we can protect from corrosion, that is called base metal. Already we discussed previous classes when we teach corrosion, dry corrosion, wet corrosion, surface coatings, all that cases we are using the term base metal. So the base metal means which we can protect from corrosion. So the base metal which we can protect from corrosion is called base metal. So here cathodic coatings means the coating, applied coatings on base metal. The coating materials are noble metals, that means high corrosion resistance metals. So in that case only it protects the base metal from corrosion or less active metals having high reduction potentials. High reduction potential because corrosion always concentrated anodic area. At cathodic area only reduction reactions takes place but do not affect the metal surface. So here cathodic coatings are obtained by coating a more noble metals or less active metals having high reduction potential or lower oxidation potential than the base metal is called cathodic coatings. So simply says cathodic coatings means noble metals or less active metals which are having high reduction potentials. So that coatings when we applied on base metal, it protects the metals from corrosion. And next question is, what is anodic coatings? So anodic coatings are obtained by coating a more active metal. Coating a more active metal having lower reduction potential than the base metal. So in this case, corrosion concentrated anodic area. So in that case, base metal acts as cathode which protect from corrosion when we apply this type of coatings. So cathodic coatings means they are having noble metals or high reduction potential less active than base metal. But here anodic coatings means these are the more active metals than the base metal. That means lower reduction potential. So in that case, that coating metals acts as anode and base metal acts as cathode. So corrosion always concentrated anodic area. So the base metal to be protected from corrosion. So that purpose we applied this type of coatings, anodic coatings on base metal. And next one is, what is hard dipping? What is hard dipping? So the base metal dipped in a molten bath of the coating metal. The base metal is dipped in molten bath of the coating metal. So which is covered by a molten flux layer. This method also used for protect the base metal from corrosion. So in this case we apply low melting metals than base metal. So here the coating metal is which type of coating applied on base metal. So that coating bath is covered with ammonium chloride flux. So in this case we dip that base metal in that coated bath, molten bath of the coating metal. So this process is called hard dipping. And next one is, what is galvanizing of iron? What is galvanizing of iron? So it is a process of coating iron or steel sheets. Iron or steel sheets. Generally these are acts as a base metal. Because these metals are generally we are using construction purpose and domestic usage also we are using this most important construction domestic use materials and less expensive, low cost available in nature. So that's why these metals we protect from corrosion by applying coating materials. So prevents from corrosion. So it is a process of coating iron or steel sheets with a thin coat of zinc to prevent iron from rusting. Galvanizing means simply we say zinc coating on base metal. So zinc coating on base metal is called galvanizing. So here base metal is iron or steel sheets. So when we apply zinc coating on base metal, that means iron or steel wire, protect the metal, these metals from corrosion. So this process is called galvanizing. Zinc coating on base metal is called galvanizing. The next one is, what is tinning of iron? Tinning. So tin coating on base metal. Tin coating on base metal. What purpose we applied this tinning? Tin coating on base metal, protect the metal from corrosion. So the process of coating tin over the iron or steel articles. So to protect them from undergoing corrosion is known as tinning. So tin coating on base metal is called tinning. The base metals are iron or steel, which we can protect from corrosion. That purpose we applied this tin coating on base metal. And next question is, what is electroplating? So electroplating is a process of applying a metal coating on the surface. It is one type of coating, electroplating. So apply coating on base metal by passing electricity through that solution is called electroplating. So here electroplating is a process of applying a metal coating on the surface of another metal through an electrodeposition process. By passing electricity through the electrolyte solution, we applied coating metal on base metal is called electroplating. Best example, nickel coating on base metal. And write the applications of electroplating. So here, what are the applications of electroplating? Electroplating means, just now we discussed already, applying coating material on base metal. Base metal means which we can protect from corrosion. So applying coating metal on base metal by passing electricity through the electrolyte solution. Best example, nickel coating on base metal. So nickel coating on base metal by following this electroplating, or copper coating on base metal by passing electricity. So that process is called electroplating. So what are the applications of electroplating? So this technique is used in industries to produce metallic coatings. Mainly this method is used in this industries to produce metallic coatings. In metals, electroplating increases corrosion resistance. And chemical attack does not occur. And hardness, wear and tear resistance. So that purpose most of this process used in the industries. So in this session we'll learn about definition, terminology of electrochemistry and corrosion. I hope understood all. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.